All right, well, welcome back, guys. So I talked a whole lot about some stuff that I wanted to do, but you didn't hear me, so I apologize about that. So today what we're going to do is try and update the Lumin package for the mixed reality toolkit to be the latest APIs. I'm already kind of halfway through this, and part of this process that I'm doing as well is actually going in and removing the Unity component things that are on here. So what I'm trying to do is get the dependencies to this Magic Leap Unity package kind of broken out, and we don't want to be dependent on this in any way. So let's see here. So let's take a look at just the packages we have right now. At the moment, we do need to have the legacy input handlers, XRTK core, the SDK, and Lumin in here. And this is the package that we're trying to get rid of, essentially, is this one from Unity, XR Magic Leap. And we want to take the latest, greatest one. What this will do is this will help us so that we don't have to be dependent on the Unity XR input or the XR package their XR manager, SDK manager. I don't know. It's a lot more complicated and convoluted than what we're using, and essentially at the end of the day, we want to operate independent from Unity, and part of that is we want to make sure that we're democratizing development in our space. So hopefully Unity doesn't cut us off from some of the things that we want to do there. I know that they want to control that whole life cycle, but I have a feeling that they're not really going down the right path. Their XR plugin system is a little bit convoluted, and it also is very heavily dependent on a bunch of native stuff. So I'm going to go through that today and try and see what we can do to get our controllers up to date. So the last little bit here is we just need to decouple our controllers from that. And there is one more thing that we have to do as well, which is get the mesh subsystem that we were kind of dependent on kind of broken out, and we want to try and get the meshes and all that stuff out independently. So we'll see about how much we can get done with that today. Right now I'm just kind of waiting for things to download here, and then we'll be good to go. So at the moment, I'm getting all these errors mainly because I removed the Magic Leap package. So let's see if I can go ahead and get the lab running from Unity. And what I'm going to do is I'm going to actually just pull in the latest from the lab and take a look at that. So give it a moment while it does this whole load here. I believe I already have I want to say I already had, yeah, this Magic Leap SDK project already installed. And I think that, yeah, we'll select this folder. I believe it's actually on the latest version of Magic Leap. So I'm sorry, Magic Leap, the latest version of Unity. So I'm just going to go ahead and grab this, and I'm going to open up this project, and it's going to live essentially side by side. So what I like about the new Magic Leap package from the lab is that they actually include all of the native bindings by default, which is absolutely amazing. It's something that I had actually asked the engineers a few weeks ago about, and they just went ahead and did it, which was awesome. So kudos to the Magic Leap engineers. They definitely hear the things that people have to say, and they implement those pretty quickly. I've never been disappointed with what they've been doing, and always just a great team to interact with. So I appreciate you guys if you're listening in. And thank you for all of the tools and the product that you've had out for us so far. Let's see here. We're still waiting for this package to update. In the meantime, I've got the lab open. If you guys have never used the new Unity, or I'm sorry, the new package manager from the lab, it's great. If you go to let's see here. Let's make this full screen here. How do I get back to bundles? Oh. How do I get back to the home page? Here we go. So here's the home page. If you guys have never seen the new lab, this is the home page. You can get to the package manager. It's up here in the upper right hand corner. If you go under My Tools, you'll probably be able to download a few other things here. But what we want to do is we want to go to the Unity Leap package here. And I'm just going to open the folder that it lives in. Here we go. And then I'll close this back. We won't really need it. I just needed this folder, and I just needed a reference to it. I'll actually, I think I already have this here. Let me go back. Where's this? Under Tools, Unity. Okay. So it's under wherever your magically decides to dump everything out at, your lab. Tools, Unity, and then the version that you'll be using. We're going to want to try and grab the latest, which is 24.1. And we're going to try and get this package here as soon as we can. In the meantime, I think what I'm going to do is I'm actually going to go ahead and close this version of Unity for our XRTK package. I'm still waiting for the other one to open. But what I want to do is, let's see here. Actually want to go into the Lumin package. And so what had happened that I noticed was that in our assets folder, we still had this Magic Leap folder, even though we deleted it. And what it is, it's this Soundfield plugin. Any native plugins, you can't delete them unless the editor is closed. So I'm going to actually close this, and I'm just going to go ahead and remove the old Magic Leap package here. And then I'll go ahead and reopen that project one more time. So finally had the new project open up. So let's go ahead and get this guy going. So this is the latest version of Unity, 2019 3.7 F1. And it has just the Magic Leap components in here. All I did was opened up the latest Unity editor and imported the Magic Leap SDK, that 24.1. And it looks like we're still getting some errors here. I think I was actually messing around with these scripts. So I may start with a clean slate here. Let's see. I might take a look at the package manager as well and see what we got in our project. It looks like we're missing the, actually missing the package for Lumin. So I'm going to actually go ahead and grab that real quick. So all packages. Let's see here. Oh, stuff's opening up on me. Here we go. We'll go ahead and install that. That should help solve some of our errors that we're getting here. All right, so it may take a second to download this. We'll just give it a moment here. I guess that's one of the downsides of the live streaming, I suppose, is you have to actually wait when all of this stuff kind of happens, which I could see that as being pretty frustrating, I suppose. All right. We'll come back to this. Still waiting for this guy. Let's see, what project is this? This is the XRTK Lumin project. Okay. So the last little bits that I have to finish here is getting the controllers set up appropriately. And it looks like I'm already getting everything out of the native bindings as it is. So what I had done was I actually created my own parser, essentially, for the project. So if I go into the Explorer here in the root, you'll see that if I go up one level here, I actually have this native bindings generator project that I was using to generate all of the native bindings here. But the nice thing is in the latest Magic Leap SDK, they provide all of this stuff for us, which is absolutely fantastic. That means that's one less thing that we have to worry about. Although I have been working on this native bindings generator, I may actually keep this around for other platforms that don't have the native bindings provided by default. So that may be something that we want to try and do in the future as much as possible. So if we go back to this new one and we open up the Magic Leap and we go into scripts here and we go into, I'm sorry, Lumin APIs, there's the bindings folder here. So it actually has all of this stuff in here already. So that's one less thing we have to do. The APIs are also great. I might just go ahead and use these. For the most part, these are all pure C# objects, although I don't really like this ML API singleton type. Is one thing that I'm not as keen on, but I also don't want to recreate all these APIs. So we'll kind of see what we have to use there. For the most part, we have everything written already for our own APIs within the XRTK Lumin, and we don't have to really use a lot of this ML API stuff. So we'll see what we need to do. That'll be interesting a little later on. So looks like all of our errors went away after we reinstalled the Magic Leap XR plugin. Let's see here. I'll go ahead and clear out the search thing here. We'll just take a look at the packages in our project. I'm really just going to be using this as reference for now. I think I removed the XR plugin just to see what are the dependencies on the Magic Leap package that we get from the lab for the newer Magic Leap stuff. And when I went through that, it was really just the meshing subsystem, and I think one other thing. We'll go back and look at this a little bit later, but I do need to just kind of decompose what's already here and see what we need to like fill in for ours. The two biggest hurdles I know we're going to run into for this is the spatial meshing and the controller stuff that we see where we're at right now. The meshing is going to be somewhat difficult. I know, because it will essentially what we're doing is we're relying on Unity's XR plugin to do the meshing for us. And really we don't want to have any dependencies on Unity wherever possible. What's interesting is that, oh, there it is. So if we go in here into their package and we take a look at this into, I believe it's actually going to be in the runtime. They have this Unity subsystems manifest. So they have Magic Leap display, they have inputs and meshing. Right now, I think for the XR plugin that we're using in the older version for Magic Leap, we only have the one definition for the manifest, which is just the meshing. So this uses the ML spatial mapper, which we don't have a dependency on in the toolkit. We actually have our own meshing subsystem. This is a mono behavior. Ours is not a mono behavior. It's a pure C# object. And we actually get a performance boost out of that as well, which is nice. But then also, let's see here. We do want to take a look at a couple of other things as well. So really that's, and then, I believe that in the runtime there is the, let's see here, this Magic Leap plugin. I believe we can actually take a look at what's in there, but I think there's actually a native, I want to say that there's a plugin for the meshing. I'm trying to remember exactly where that's at. Windows, I think it's this one here. One of these is a native, yeah, this is the native one. This Magic Leap native DLL. This is where all the meshing happens. The spatial meshing happens, and it's all like C++ low-level native stuff, which I really don't like. I was under the impression that Unity was actually getting away from using the native stuff as much as possible and like rewriting everything in C# wherever they could. I thought they were trying to do everything like that in the editor. I suppose it's specifically for performance reasons, but that also makes it harder for us because we cannot use whatever they have inside of this, nor can we kind of look at what's in there to see, you know, what exactly they're doing to take this data and give it Unity types. So we're going to have to actually build all of that stuff out on our own. So that's the big roadblock that we have. We'll see what that entails. I'm not really sure. I'm not looking forward to it at all, but it is something that we're going to have to address at some point. Okay, so we do have, I can do one of two things. I could focus on what I have left, which is just this controller reference here, and getting the last of that, because we have all of our native bindings that we already generated out using our other native bindings generator, or we can use the latest from Magic Leap's. What they did was essentially, you know, they have this, if we go in here, they have this, under this Lumin folder, they have the APIs, the bindings, and the utilities, which essentially is, looks like just a couple of extensions for known types. This ML device, we don't really need this. It does some weird stuff and does some instancing things like our service locator. But then it also gets some like frame callbacks and some other things that I don't think we really need. But it also enforces the clipping distance, which I know a lot of people don't necessarily like. And we don't necessarily need to have those. We can actually do quite a bit of stuff. Some people think they're hard-coded in, but really it's not. But we could use the bindings that they provide, just because it's, you know, it's already here. One other thing we can do is we can just double check to make sure the bindings that we're generating look similar and act similar as well. So we can do some testing, like some A/B testing as well, to make sure that that's all working correctly as well. I guess we'll kind of come back and take a look at that. So one thing I am curious about, though, is essentially what they look like. So I think for the most part, ours look similar. Looks like they're using partial classes. I don't think I use that. These also have constructors, which I don't think we actually need. A lot of these things are all static anyway, so I'm not really interested in that. Their documentation is definitely better. I am producing the documentation for our native bindings, but I'm not really sure that it's coming out exactly the way that we want. So I guess we could do a one-to-one comparison of some of these to see exactly what they're looking like. I know I don't do this here where we're defining this. I think we actually have it generate out all of those on their own. So let's just take a look. So in our native bindings, let's see here. This other class that we had open, Magic Leap native bindings. This is just a base class that looks like for some of these enums for getting the latest snapshot, getting the snapshot transform, and then getting the results to string, Magic Leap, try get pose. Interesting. So these look like Oh, that's interesting. What does that go to? Unity Magic. That goes to the Unity Magic Leap SDK. So that's not even the native bindings for their DLL. Even Magic Leap is calling into the Unity Magic Leap DLL, which is interesting. I would assume it would be the other way around. There's some weird things where the engineers are not really working together here to get the right things out to the developers. I guess we'll take a look at this a little bit more. So I want to do one-to-one comparisons, but I don't think that these will be one-to-one. So see, we got this ML API. For ours, what this does is we do have a couple of constants where we get the result prefix. We got an invalid handle prefix. This is all of the global results that we could get. This is all generated by hand. None of this is should be edited directly because likely it'll get it'll get overwritten at some point. So we try and minimize having to do anything by hand for the native bindings as much as possible, essentially. So we do have some results, and we're doing some casting. And by the way, if you're curious about where I got this, there's this guy, XOOXFX. I think that's his name. Honestly, can't remember at the moment. Here we go. Here it is, the C++ AST CodeGen. Zoof is actually a Unity developer. I think I believe he works for Unity. I'm not 100% sure. He's definitely in the Unity org, so I'm pretty sure he's a Unity engineer. But he was working on this some time back, and I kind of noticed, and it was one of the better ones. It's also under construction still, from what I see. So I'm not really sure. I haven't really checked in with this recently, so I might want to go do that and see how far along it was. But I did have to make a fork and do some, I even opened some issues here for him. So not really sure, how to get this to work correctly. So we may still have trouble with our code gen, just because there are some issues there. We'll see what happens. But essentially, I'm using his to do the code generation and a light modification to do a lot of this stuff. So what that did is now we have our XRTK Lumin native bindings ML input, and we can get everything essentially pulled directly from this thing. But again, there are some issues with like the namings of some of these input types, and then also how we're getting the documentation parsed out as well. So it's hit or miss here. I'm not 100% confident that everything is getting out the way it should be. So we'll see what happens. I wouldn't mind using the Magic Leap native bindings themselves, but again, we saw in the other one that they have dependencies on Unity's XRTK libraries here. So that is somewhat, unsettling and also frustrating, because I would just like to use that stuff outright. We'll see what happens. Okay. So, worst comes to worst, I can just copy the documentation. That shouldn't be covered under anything, really. But even this documentation, I wish it would reference back to the types it's actually talking about. So this should actually be this. Maybe not, actually. I guess it is. Anyway, so even their documentation has some problems, but that's okay. I'm not really too worried about it. Documentation really is just for being able to get things out a little bit easier. Okay, so I think I'm just going to finish what we're at on ours. I would love to use the latest, but I have a feeling that it's just not going to happen. The other thing that I'm quite concerned about is, no, I don't want to save that. The other thing I'm quite concerned about is the meshing subsystem, but I guess at the moment it's not really going to be that big of a deal. Alright, so let me just check to make sure we're not, so we got over here. I'm just checking my messages real quick, guys. Sorry about that. Alright, so these ML controller reference types. I'm just going to go back to my changes real quick and check to see what we got here. So done quite a bit of stuff where we've removed the controller reference, which was calling back into this ML input controller, which was part of their SDK. At the moment, I guess what I'm trying to do is remove the SDK dependency from the toolkit so that we're just getting everything from the native bindings directly. So this was kind of a twofold thing. So if I go back here, I'm going to go ahead and close this. I'm not going to worry about the updated Magic Leap SDK right now. I'm just going to focus on what we got left to do here. Let's see, get the native controller state. What this does, gets the result, handle. I'm not even 100% sure some of this is really working the way that we want either. So, one thing I want to do, I want to import the support libraries. So what I'm going to end up doing while I work on this is actually stream to the device. And I'm going to get the device set up and plugged in here in a minute. But I want to make sure that the streaming is working. So Magic Leap Remote, launch remote. And this is the old one still. So I haven't updated the APIs for this yet, for the latest. So this native input binding, or I'm sorry, the native bindings for this is, I believe, an older version. So let me take a look real quick. Well, go ahead and open up this Lumin native bindings project as well. I want to say that it is one of the older ones. I can't think of exactly which one. Opening up that project will tell us though for sure. All right, so let's go to our main program here. Our program class here. This will actually tell us what it is that we're doing. So it looks like 220 is the current API that we're targeting for this. So we'll update this in time. First, I want to try and get the last of this kind of figured out, and then I'll get to updating it to be the very latest 241. let's see here. Let me go ahead and get the device plugged in and set up. So give me just a moment here. You might hear some noise in the background, but that's just me fumbling and or knocking stuff over. Let's see here. Is this my cord? That is my cord. All right, so I'm gonna go ahead and turn the device on now. Kind of glad I don't have my webcam on for this because I always feel like I just look like a really strange, crazy person whenever I put these devices on. All right, so let's see here. Just waiting a little bit longer while the device turns on and boots up. All right. All right, so we are all set up here. Let's see if we can go ahead and start the server. All right, so I actually have the device connected using the hub and all the other fancy gadgets that come along with that. So that looks good. We just need to get rid of these errors and we can start checking on our types here. So what I was doing before, essentially I was getting the native controller state. So I'm actually calling into the native bindings and I'm going to get the current controller state and get all of the current results from the controller at this moment. Let's see here. So we get the result and we have a reference to the controller system state. And we'll probably be using this here for whatever it is we need to do. Let's see, the controller system state. Let's see what this returns for us. What we want to do is get the reference type and actually do the same things here. So this is where I was kind of getting lost, and this is kind of where I stopped. So it may take me a moment to kind of re-figure out where I'm at. So a couple of things we need to check here. We need the position and orientation, and then the current controller DOF and the calibration accuracy, I suppose. And then the current controller reference type. So not really sure how this kind of works. So the controller state, I'm not sure if we have is synchronized, is read only, is fixed, length, long length, sync root. I have no idea. So I guess there's an array of controllers that we can get back. There's the accuracy, and then that's the controller ID. So that's the calibration accuracy, I suppose, that we're wanting to get, which would be medium. So my problem is I don't know why there's an array of controller states. And if that array of controller states is for the left or the right hand, or even the other input types that Magic Leap supports. I think that they even support like a Wacom, which is kind of interesting. I don't know if that's for like their runtime on the iPad or something. It's just kind of bizarre. But I guess we'll kind of go through this one at a time. So Not only that, but we also need to know about the controller's degrees of freedom mode. So that's interesting. Calibration accuracy for the lightware. That's not even for the controller, but that's for the headset, I believe. So I have a feeling that there's a couple of different states, and each state is for each controller stream, I suppose. So if we take a look, so we got accuracy, controller ID, it's either 1 or 2, but then there's also the stream. So I'm guessing that the stream is supposed to be the actual data that we're getting. So there's the coordinate frame controller is active, and then the mode. And I believe the mode is that DOF thing here. So there's the other thing that we're looking for. So we were looking for the accuracy, which we found, and for this degrees of freedom, which we also found. The last two things we'll need is the position and the orientation. So I'm just going to go ahead and comment this out. So we got the mode, controller system state, controller state, and I'm just guessing here on the ID for this. Really, I'm not too worried about what that's going to be at the moment, because once we figure out, you know, like the left or right controller, and then, you know, I think we'll get there at some point. So this is the DOF. So we're going to be replacing this with this. All right. And then we're going to be replacing this with this. All right, so the last two things we need to figure out is the position and orientation. So I believe it's going to be this controller system state, stream that we're going to be getting it out of. And I guess it's this coordinate frame controller. And then the data, which is an array of a bunch of stuff. But I think that from the ML API, we can actually get no. ML coordinate frame UID. So that's the type that we're going to get back. But I want to know is how do we utilize this? So I believe that there is something where we can get the coordinate frames. Yeah, ML snapshot get transform. This is what I'm looking for right here. So what this does is it gets a transform between the world origin and the coordinate frame ID. So this is what we want, and this is in ML snapshot. All right, so ML snapshot. Let's see here. Get snapshot result string, get transform. So I think what we do is we pass in the snapshot. I don't think I have a snapshot though. I think that this is just the, it just returns the ML coordinate frame universal ID. So we'll be passing this into this because it needs an in reference to the reference ID, and then we also need a reference to the ML transform type. So the transform will be coming out. The problem is I don't know how to get this ML snapshot from the controller. This will be interesting. Yeah, I'm not really sure. So nowhere else is this really being used. So this is where we can kind of go back to the other project and kind of reference where maybe Unity is using this in some way, or they're doing this. So let's go back and open up the other project real quick just so we can take a look at this. Let's see, ML snapshot. What is this exactly? So we do have this. It's essentially a struct with a handle, and it's got some other data associated with it. Interesting. I'm actually going to take this headset off. It's hot. I'm just going to leave it on while we're doing our thing, because we're going to eventually get to the point where we're going to be streaming this back out. ML perception, ML get snapshot out. Let's see what this does exactly. Pull in the latest state of all persistent transforms and all enabled trackers extrapolated to the next time frame. Okay. Release the specified ML snapshot object. Well, so that seems interesting. So we're creating a snapshot using the ML perception library. But then if we grab that snapshot, we also need to release it too. So that's somewhat interesting. We also need to initialize the perception, and then we also need to start it up. Start the perception system, initialize the perception system with the passed in settings, and then we also need to set it up and then run it. So I bet the ML API handles a lot of this stuff in some capacity. We may need to add this kind of support somehow in our data provider. So this will be interesting. All right, well, we'll come back to this. I'm not 100% sure yet what exactly we need to do. So I know we need to get the snapshot, or ML snapshot get transform at some point. And we'll probably need to get this coordinate frame controller to get the position and orientation of our controller at some point. I think in the meantime, what I'm going to do is I'm just going to go ahead and comment this section out so we can get it to compile. And I would like to at least try and get everything up and running for the most part. So what I'm going to do is I'm just going to comment out each one of these methods where we're updating the input data, just so that we can kind of get an idea of if our native bindings that we've been implementing are actually getting up and running. So that'll be the important thing for me to know, if we can get this native controller state and making sure we're getting that data. So I'll go ahead and do this. This is the other project I went ahead and opened. We'll give it a second while it regenerates. And let's see, our remote's still running, so that's good. I'm gonna go ahead and put the device back on my face. and we'll go ahead and play in the editor and see what we come up with. We do need to be on the right. We do need to be in the right scene though. So give me 1 sec here. Oh, that's right. It's a read-only package. So I believe we have a test scene already. Here we go. And let me just make sure everything does look somewhat set up correctly. That does. All right, cool. So we'll go ahead and play, see what we get. Explosion. All hell breaks loose. Not really sure. It's going to take a second here while I guess it tries to... Oh, no, it just went ahead and crashed. All right, well, I don't know if that's good or bad, but let's take a look. Editor log. Go ahead and take the device off my face too. All right. This is fun. Loads of fun. So it looks like we got a bunch of dirty stuff here that happened. I don't know why this is all in the editor like this, but looks like the log is dirty. We'll update later. Let's see here. Could not load something. That's not a big deal. Initialize service locator. We got a bunch of stuff going on here. Windows mixed reality, data provider, not worried about that. Oculus, again, not worried about that. Input tracker was created successfully. Here we go. So here's some of the ones from our Lumin data provider. All right. On connect, controller tracker was created successfully. It seems as though all of this is kind of running okay. Not 100% sure about what, excuse me, I'm not 100% sure about what happened, but we can also take a look at the crash logs as well. I believe those are in a different place. Not 100% sure. It's been a little while. It didn't say that the editor crashed. So that's also somewhat interesting. It didn't say that it crashed. So we don't have a crash log. So that'll also be somewhat frustrating to find. We do know that the last log that we hit was from controller data provider 334. So let's take a look at that real quick. This is where we got data, and this was the pointer for our controller, and we raised the input source was detected, and then we updated our controller. So this was the last log that we got. On connect 00, 332. Lumin controller data provider 202, and then 334. I guess in the Git controller here, we go through here, tracker was created successfully. Why are we resetting the input handle to 0 though, or to being undefined? This is interesting. I'm not sure why I do this. I'm going to go ahead and remove this, or I'm just going to comment this line out. I'm not really sure why I'm resetting this. I think it's because later on, I actually passed this in somewhere. Seems redundant. Same with these, I suppose. You could go line by line. I'm going to try commenting out resetting that input handle for whatever reason. I'm not sure why we're doing that, but I want to make sure it's for a good reason. But it doesn't look like we're actually using it yet. We're also not using this controller states as far as I know either. Because what we're doing is we're creating a new controller, and then the controller is going to be handling some of this. So again, I'm not really sure where I need to be putting some of this stuff, and that's essentially what I'm trying to work out here. So the Lumin controller data provider really should just be handling the controller itself. We end up not using the input handle at all. Here we check to see on enable if the input handle is valid or not. And then we create the input handle here. And then we pass that in to our controller callback result. Interesting. Yeah, I don't think we should have been resetting that there. That could be part of the problem we were having. Okay, so I went ahead and removed that. And then let's see here. Let's go ahead and get the editor back up and running. This was the other Unity project. Not really worried about that one. All right, while the Unity editor updates, I'm just going to check my notifications and my chat window in case any of you are talking to me. Alrighty. Just going to check the stream, make sure it's still healthy. Okay. And let's see here. Let's get back into what we were doing. So let's see if we can get this to start one more time. One other thing I think as well that we actually need to do is, in order for this to work, I believe we need to have the editor set to OpenGL. Oh, it already is. Great. I'd already updated the project for that. So if you are using the streaming, the ML remote to stream from the device to the Magic Leap, you do need to have OpenGL as your graphics API for Windows for that to work. So I'd already done that, which is great. All right, so I'm going to go ahead and put this back on. Initialize the head pose. All right. Give it a moment while it tries to regain the head pose. Restarting in 5 seconds. All right, so now let's try again. Oh, we're not in the right scene. Let's see here. Well, it did work. So that worked. That was great. Although I do have extra scenes and stuff that are running now. So yeah, it was that I was resetting that input handle for whatever reason. I'm not sure why that was there. I don't know what I was thinking. But that seemed to be the fix. So input tracker was created successfully. We do have a marshalling directive exception. Structure field of type ML controller state can't be marshaled as LP array type. So that'll be interesting. I'm not sure if that's going to be an issue with the native binding generator, or if maybe I had made a change somehow in that. All right, I'm going to go ahead and take the headset off for a second. All right, so for whatever reason, the editor is definitely stuck in between play mode states. So I'm not really sure what's going on here. So I'm going to go ahead and do my best to just kill the process for Unity here. Not sure what it got hung up on. We'll have to take a look at that later. In the meantime, I think I'm going to go ahead and just close out this other version of Unity, the instance of Unity, because I don't know if it's eating up my performance. So I want to try and minimize the amount of resources on my machine at this time. All right, just waiting for Unity to launch that editor again. While I wait, I do want to just take a look at the previous editor log. Mainly just because I'm kind of curious about some of the log messages, and maybe it'll also kind of tell me or hint at why the editor locked up when we were exiting play mode. It looked like it shut down okay, even though I killed the process. So this is kind of interesting. And install the update. So we were able to successfully set the callbacks for the controller input events. And we were able to successfully create the input tracker for the device itself. So those are good things. It did not shut down correctly though. As I can see here. Let's see. Yeah, I didn't seem to shut down the toolkit correctly. So we'll see what happens when we try this again here in just a moment. Okay. So I'm not sure if it's getting upset because we're setting the input handle here. But I'm just going to go ahead and remove this one too. And see if maybe that could also be part of the problem. Maybe it doesn't like us writing to that value. Let's wait for the editor to reload one more time. The great thing is I did get the stream to start on the device, and I did see the Unity scene on device, so that was great. It did seem like the controller trackers were being initialized correctly, so that was also great. Let's make sure we're actually in the correct scene this time. All right. Cool. Okay. And one last time, let's just make sure this is remote server still on. Great. Go ahead and press play. Okay, so we are getting the, so I'm actually able to turn my head and everything, so that's great. So it seems as though we are getting the head input, although I don't think the head input is quite correct because of I don't think our pose driver is working correctly. Yeah, I don't think this is set up correctly, but that's fine. Not really too worried about that. Yeah, it's a little bit off, but that's all right. So it seems that we were able to enter play mode. We did get input tracker created successfully, and then we got an event on connect with the 0, controller tracker was successfully connected, and then we got this other error. So we'll take a look at this. Hopefully this, oh, no. So we are going to get a crash, C++ runtime library. All right, awesome. This is part of the great experiences of working with native code in a managed environment like Unity. Cool. So again, I think I just need to go to Task Manager and just kill this process one more time. What kind of sucks is I actually got a decent error out of that last one. And I want to try and nail that down. But first, I want to try and figure out what's going on in our shutdown process that it doesn't like. So that'll be an important step that we'll need to do. Let's see, I'll go back to the editor again, and I just want to take a look at the current editor log. Let's see if it ever opens. All right, let's scroll down to the very bottom. I'm sure we'll get a crash report this time, I'm sure. XR remote setting loader callback. Interesting. Okay. Backend bake switch. I think that's actually the remoting service. We did get this, which is great. So this is actually coming from, oh, I don't know actually. Wrapper managed to native, Lumin bindings ML controller, get controller state. Can't can't be marshaled as an LP array. So we'll take a look at that here in a second as well. I should have had the editor trying to start back up again. I thought I had launched it, but maybe I'm thinking I had and didn't. All right, so geez. That's why I didn't launch it yet, is because I wanted to look at the editor log. That's what's going on. Okay. So now we need to open up the previous editor log. I guess this is, oh yeah, we're down back at the bottom again. Okay, cool. I'm gonna go ahead and just copy this, because what'll happen is if I copy this and open Visual Studio, ReSharper should take me straight to the lines that I'm interested in, which is great. So our exception callback stack essentially looks like Lumin controller data provider enable, and then it looks like we did the native bindings here. We set some controller callbacks on controller connected. Then we get to the controller. And then here, I suppose when we've created the controller, we call update. And in that update, we try and get the controller state. And that's kind of what we were looking at before here in the Lumin controller, where we were looking at the states that I was trying to figure out how to get these. So get controller state. Let's see if there's other places that I'm actually calling this, because I'm not 100% sure. All right, so it does look like we're also calling this in the data provider itself. And this is inside of the get controller. So I'm actually going to go ahead and comment this section out, because I think we're actually doing this already. Although, oh, look at this. I already have a frame ID. It looks like I've already tried to figure out how to get the snapshot transform for that. So that'll be interesting. So it wasn't coming from the ML controller. It's coming from the data provider still. On this line here, get controller state. I have a feeling this is where it is failing. Do we have a reference to this controller handle yet? ML API handle? Okay. I believe it said the controller handle tracker was created successfully. The structure of ML controller state can't be marshaled as an array. So, or as the type that we were looking at. So let's just dive into this real quick. So this is saying that this can't be marshaled as an LP array. All right, well, let's take a look at the latest bindings for the Magic Leap SDK. And let's just reference this ML system state and see what kind of type that it marshals it as. Let's take a look at what this is exactly first. Information about this controller. The controller stream. I'm wondering if we're going to have the same problem with the controller stream not being able to be marshaled as an array either. So this is kind of interesting. I'm not sure exactly what I was doing here. I think I was just trying to get the latest information from the controller about like handedness and all sorts of other stuff, but I'm honestly not too sure about the implementation here. But this is essentially what I was trying to do in the Lumin controller in that section where I was like, I give up. This section here essentially is very similar to this section here where I was having that marshalling error. What we're doing is we're getting the snapshot transform, and we're able to get the result and then get the actual data that we need out of it. So that'll be important later. All right, so let's take a look at the input native bindings. Oh, actually, I think it's the ML controller native bindings that we really want to look at. So we'll wait until Visual Studio opens. And the type we're looking for is this ML controller system state. Or get state, rather, should I say. It seems like still trying to index all of the classes. It takes a lot longer when you're streaming. Got some tablet device callbacks. Interesting. You can get the device states to a native array structure. That doesn't seem very... I don't know why a lot of this extra stuff is in here. It doesn't really seem like it's specific to the device itself. It seems like they're trying to also have their own Lumin OS on tablets as well, I guess. I don't know. Pin touch, touch ring, tablet ring is touched. Interesting. Still waiting for still waiting for this to catch up a little bit. Get controller tracker active. Gestures enabled. Feedback pattern vibration LED effects. Controller configuration native. It looks like they've removed some of these things. So we can update the configuration. It doesn't seem as though that this stuff is really being used anymore. This is under ML input. Well, let's use ReSharper's awesome fuzzy search feature to see if we can get this ML controller state. Sure. Here we go. Partial class controller. Try get feature value. So they're getting all their stuff from Unity's new XR input system, which I am not particularly thrilled with. Interesting. So the new API does not have any of the old references to their native. So they're going through Unity's things, I suppose. Makes it a little bit more difficult because then I'm going to have to grab the old ML API and see how they're doing that. Let's see, testing 1 2 1 2 test. Hopefully my stream is still healthy. Just checking this out. It says error, not receiving enough input. I think for now I'm going to go ahead and end the stream just in case. And we'll see what happens. I'm going to go ahead and try working on this a little bit more on my own. Just to not to bore anyone really. But we'll see what happens here. I'm gonna try and get the old API sorted out and seeing if I can get the references for like what the type should be. Hopefully that'll help. I'm not really sure if that'll help or not. I gotta figure out what types these need to be marshaled as, and that'll help out immensely. If I could do that, I think I'll be able to figure out the rest. We'll see what happens. So right now I know I'm stuck here. getting the controller state. It seems like either Unity isn't happy about the way we're marshalling this, which is causing an exception that essentially is keeping it from being able to close or shut down the Magic Leap data provider. So we'll come back to this a little bit later.